Example 5. Y is x minus 1 squared. So this behaves like y, which is x squared. If x is equal to 1, that's like x squared above, right here. It's the same type of curve, but the vertex occurs where the quantity that I square is 0, so x is equal to 1. You have the same curve that you had earlier, but it is shifted 1 unit to the right. X plus 2, this is like y equals negative x squared. And when x is negative 2, you find the vertex. So this is the parabola which goes down along the y-axis, and it's going to be shifted 2 units to the left. There we go. This is like x equals y squared, so that's a parabola that opens to the right. And if y is equal to 3, you go up 3 units, and you get your curve. Like that. So x is equal to y squared. X is positive, and y is plus or minus about the line y equals 2. That's your axis of symmetry. And then I should have one more example. X, which is negative quantity squared. X is always negative. If y is equal to negative 4, I find my vertex. So at negative 4, I get my vertex. And this is like x equals negative y squared that we have seen before. You can slow this down and study it. And then you have y which is x squared plus 1. We just plotted y which is x squared. And to all these values of y, we add 1. So we got the parabola y equals x squared, and it moves up by 1 unit. Just like that. Here we have y which is negative x squared. That's the parabola that went down along the y-axis. And we add 2 to all the values of y, so the entire curve goes up by 2 units. Like that. And you can find 3 points on here. You can find where you cross the x-axis, the x-intercepts, and you have a y-intercept. And you have symmetry. So you don't need a whole bunch of points to graph that. You have x equals y squared. X is positive. Your curve goes this way. And whatever x is, you subtract 3 from that. So the curve y equals x squared shifts 3 units to the left. Here we go. Again, you can find y-intercept here, y-intercept here, just to give you more points on the curve. That I should have a slash here, and you would see a nice square root of 3. I'll go and fix that. X equals negative y squared goes that way. And to all these values of x, to all these values of x, you add 5. So that curves move 5 units to the right. Like that. Okay, I don't know how many more examples I have. I should have cut it off. This is like y equals x squared. So you have a curve that goes like that. Then you shift 2 units to the left. And then you add 3 to that, so the entire curve moves up by 3 units. Okay? So first I have y, which is x squared. Then I have y, which is x plus 2 squared, 2 units to the left. And then I add 3 to all that. See how that works stepwise? This is essentially the same thing. I start with y, which is negative x squared. The origin, the vertex occurs when x is positive 1, and y will be 0. And once I have that, I add 4 to all these values of y. So y equals negative x squared. And then minus 1 shifts it 1 unit to the right. And plus 4 shifts it 4 units up. So your vertex is at 1, 4. You can find a y-intercept by plugging in x equals 0. You can find the 2 x-intercepts by saying y is equal to 0 and solving this. Easy to solve. Add this term to both sides. You have a perfect square. Take the square root of the both sides. Don't forget the plus or minus. You got 3, 0, negative 1, 0. Example 15, just like what we had before, you can study it. This is my curve. Example 16, just like what I have been telling you, I let you study it. I have the details right here. This is my curve. And then I am doing a proof of how I can get a perfect square. I completed the square like we described before, and this can be written in the form of a x minus some number squared plus k. The vertex occurs where the quantity I square is 0, so x is h. If x is h, this drops out, y is k. And if you solve this right here for 0, you get x, which is negative b over 2a. You could find your vertex by using that formula. X is negative b over 2a. Plug it in and find out what k is. Personally, I prefer completing the square. And then, I got another example here. Complete the square. You take, once this is 1x squared, you divide the coefficient of x by 2, you get 3. And the constant that you need here is the 3 squared. So these 3 terms give you a perfect square. And I added 9, and I subtracted 9, so I added 0. I didn't change that. I made that plus 0. Vertex at negative 3, negative 9. X-intercepts and y-intercept. The y-intercept happens to be just like the x-intercept at 0, 0. Okay, I got one more example. Complete the square here. I let you look at the details. I have the details right here. And if this is correct, and I'll go and check it, I get a vertex at positive 3 over 8 and negative 1. And I know which way this opens up. This is like y equals x squared, so it opens up like that. Like that, shifted to the right 3/8 units, and then shifted down 1 unit. Here we go. And then I trust I get exercises. Ooh, this